So I'm going to go over the 2019 number 6, which was a recommended question that College Board suggested that you guys review for practicing for the 2020 exam. So here's the question, 2019 number 6. Functions f, g, and h are twice differentiable functions. So before we continue, twice differentiable means that all three of these, that you can find their second derivative, which also means then, so you have to remember what twice differentiable implies, that these functions are all continuous, and since it's twice differentiable, then their first derivative is also continuous, okay? And then you have g of 2 is equal to h of 2, which is equal to 4. So that basically means that for your g function, you have 2, 4, and for h function, you also have 2, 4. Okay? And then they said the line y equal to this is tangent to both of g at x equal to and this. Okay, so this is the same tangent line to both of those at that point, okay? And you can see that this is y minus 4 is equal to 2/3 x minus 2. Okay, so all I did was subtract the 4, and we have it in that point slope form. All right, so part A, it says to find h prime of 2. Okay, so before I do this, remember when you're taking your test, the first thing you want to do is write your AP ID number at the top and your initials, and write the page number just in case you end up using multiple pages, okay? And I'm going to write 2019 number 6. All right, now you're going to label each part. So you have A, B, C, D. So here's part A. Find h prime of 2. Okay, well, h prime of 2. Well, they don't give me a function to find the derivative, but they did give me a tangent line. And the tangent, the slope of the tangent, is the derivative. So that means that h prime of 2 is equal to 2/3, because this is the point 2, and this is its tangent line, so that slope is 2/3. Okay, if you don't remember exactly, well, remember that it's y minus, and in this situation we'll do h of a is equal to h prime of a x minus a. That would be the slope of the tangent. So this h prime of a matches up with 2/3. Okay? All right, part B, that was easy. It says, let a be the function given by a of x. I'm going to write this down. A of x is equal to 3x cubed h of x. Okay? Write an expression for a prime of x, and then find a prime of 2. Okay. So a prime of x is equal to, well, this is with respect to x, and so I have two expressions multiplied together that are with respect to x, and so I'm going to do the product rule. So I'm going to do the derivative of the first, so bring down my power, so it's going to be 9x squared times the second, h of x, plus, then I'm going to take the first expression and multiply it by the derivative of the second. So that's what I've got, okay? And I always like to go back to the, okay, so I've got that, yes. Okay, so now what is a prime of 2? So now we just substitute that in. So this is going to be 9 times 2 squared h of 2 plus 3 times 2 cubed h prime of 2. Now, they did say that you don't need to simplify your work, but you do need to evaluate these. They need to see that you know what these values are and how you get these values, okay? So you do not stop here, okay? You could just leave this like this, and so I'll go ahead and do that. I'll say 9 times 2 squared, and what is h of 2? H of 2 is 4, so you're going to substitute that in, plus 3 times 2 cubed, and h prime of 2, we already discussed, is 2/3. And you can leave it like this. You don't need to simplify, okay? For this year's test or the prior year's test, you could have just left it like this. But you do need to evaluate these expressions, okay? Until you get down to this point. All right? So that's the end of that, part C. Says the function h satisfies this. Okay, that's involved. H, okay, well, let me write this down. So h of x is equal to x squared minus 4 all over 1 minus f of x cubed for x not equal to 2. Okay. All right, so I have this function, and it's in terms of a different function, okay? It is known that the limit as x goes to 2 of h of x can be evaluated using L'Hopital's rule. Okay, so what does that mean to me? That I can take the limit of this, and I could use L'Hopital's rule. So if I had to use L'Hopital's rule, I had to have gotten an indeterminate form, okay? Use this to find blah, blah, blah. Okay, so it says that it's for not for x equal to 2, but also remember that they said that this is continuous by saying that it's differentiable. So, and that f of x must also then be differentiable. All right, use this to find this and this. Okay, all right, well, I'm going to figure this out. Well, I'm going to figure this out as I go. So this can be evaluated using L'Hopital's rule. Okay. So I have limit as x goes to 2 of h of x can be evaluated using L'Hopital's rule, which is limit as x goes to 2 of x squared minus 4 all over 1 minus f of x being cubed, right? Okay, so now, like I said, this must be continuous. Okay, so you're using, let me refer back to continuity. I'll do it in this term. H of a exists. Limit as x goes to a of h of x exists, and limit as x goes to a of h of x equals h of a. So this is continuity at a point. Now, even though they said that this function, h of x, is this function for not x equal to 2, that doesn't necessarily mean it's not continuous at 2. It could have a hole at 2, but then that hole could be replaced with this point that they gave us right here. We can fill that hole in with that point, and then all of a sudden it becomes continuous. So we do know that if I replaced this with 2, it exists because it's given. And they did say that we can evaluate it, and not only that, it must exist because since it's differentiable, it must be continuous. So then if it's continuous, that means this is equal to this, which we know that is limit as x goes to 2 of h of x is equal to 4. So therefore, this expression right here is equal to 4. Okay, so now I know that this has got to equal 4. Now I have to continue. All right, so I'm going to work on this little by little. Limit as x goes to 2 of x squared minus 4 all over 1 minus f of x being cubed. Now they said that we can find out that this is 4 by using L'Hopital's rule. So that means that we had to have an indeterminate form someplace, okay? Now I can see already that when I put the 2 in, 2 squared is going to give me 4, right? Okay, so if I do limit as x goes to 2 of x squared minus 4, that will give me 0 in my numerator. So since that's going to give me 0 in my numerator, that means this has got to be 0, right? So then that means that limit as x goes to 2 of 1 minus f of this being cubed has to also equal 0. So what does that mean? That means then when I put in 2 here, 1 minus f of 2 being cubed has to equal 0. So if I solve for f of 2, this is going to be negative 1, and so that means f of 2 has to be 1, okay? Because divide out the negative and cube root it, that's going to be 1. Okay, so that helps me figure out what f of 2 is. All right, yay. So I've got that. Okay, and I'll rewrite that someplace else later. And now I need to find f prime of 2. So now that I have this, this is an indeterminate form, okay, which means then I get to take the derivative of the numerator and denominator using L'Hopital's rule, okay? So I'm going to go limit as x goes to 2. The derivative of the numerator is going to be 2x. And the derivative of the denominator with respect to x is going to be, well, that's going to be 0. And then I'm going to have negative 3 f of x being squared. But times, you have to remember, you have to do the chain rule. I like this problem. F prime of, oops, not 2 yet. Prime of x. Yes. Okay. All right. So now let's see. I know that's got to equal 4 in the end, right? So let's see. If I put 2 in there, then I'm going to have 4 all over negative 3. And I already know what this is. Oh, well, first let me write it all out. F of 2 being squared times f prime of 2. Okay, I'm substituting 2 in now, okay? And that's why I didn't write limit anymore, okay? And I know that this has to equal 4. So I have 4 all over, and this is 1, so it's going to be negative 3 times 1 squared. I'm going baby steps, times f prime of 2 is equal to 4. And so now I'm going to go over here, and so I'm going to divide out that 4, and I'm going to have 1 over negative 3 times f prime of 2 is equal to 1. I divided 4 from both sides. And so that means then I'm going to multiply this guy out. So I'm going to have 1 over negative 3 is equal to f prime of 2. And so now I have that. And show the work that leads to the answer. So I'm just going to say that f of 2 is equal to 1, and f prime of 2 is equal to negative 1/3. Okay? All right. And so now I have used my entire page, and I'm going to part D. And it doesn't require graph paper, but my notebook is that way, where you have paper and then graph paper. So I'm going to put my AP ID number. I'm going to put my initials. And now I'm going to write that this is page 2. So when I submit it, they know which order my work goes in case I submit it the wrong way. And then I'm going to write that this is part D. Yeah. And now let's look at part D. Okay, it says it is known that g of x, okay, I like to write things out because it's easier for me to remember. G of x is less than h of x, be equal to, for this interval. Okay, so let k be a function satisfying this. Okay, so g of x is less than or equal to h of x. Now, they had equal to because, remember that when x is equal to 2, they are actually equal to each other. okay, when x is equal to 2. Let k be a function satisfying this. So now that means k is in between or equal to, because there's equal to all the way across. So you have g of x, k of x, h of x. For this, is k continuous at x equal to 2? Justify your answer. Well, here's the thing. Since this one and this one are both continuous and differentiable, okay, and k is in between here, then, and it's going to be less than or equal to. Now, since at x equal to 2, these two functions, the outer two functions, are actually equal to each other. If the outer two functions are actually equal to each other, then what does that mean for the middle function? I'm going to say by the squeeze theorem. Yes, baby. Can I have a message? Yes, baby. 1 minute. Okay. Then by the squeeze theorem, wait, I should write this. I should write my whole statement. Since g of x and h of x are both continuous and differentiable on, what interval are we talking about? 1. Then by the squeeze theorem, I would say that then by the squeeze theorem, hello. Okay, I'll say that limit of x. Okay. So go back to your room and I'll change you in 1 minute, okay? Is equal to 4, okay? Because the squeeze theorem forgot this. The squeeze theorem involved limits. So the limit of this guy and then the limit of this guy. By the squeeze theorem, the limit of this one will be the same, okay? If these two are equal to each other, okay? And, okay, baby, here you go. And therefore, k of 2 is equal to 4. And that's it. Thank you.